Hello and welcome to the lecture on hearing. Hearing, of course, is happens through your ears, and hopefully you've already watched the lecture that was over the anatomy of the ears, because the external ear, the middle ear, and the inner ear all do different things for our hearing. Okay, so hopefully you have these notes down and this is familiar to you. Hopefully you understand the ossicles. Hopefully you understand that in your inner ear, you have three parts in there. And those three parts are all responsible for different things. So I'm going to talk about the cochlea during this lecture. And the cochlea is how we hear. The other parts of the ear are going to be associated with our ability to balance. Okay, so a couple of things that I need you to know is the cochlea is the spiral-shaped, snail-shaped part of your ear. And it's a tube that's wound smaller and smaller. And there is a duct. Please remember what a duct is. A duct is a passageway from one area to another. So normally students are familiar with like air ducts, right? So the heater, the air conditioner in the classroom comes out through the air duct. So it's a passageway where air can pass through. Well, in this case, it's the passageway that sound can pass through. And sound, as it comes into the ear, will vibrate, of course, the ossicles, as we've already talked about, and it passes through the oval window. And then when it passes through the oval window, it can travel in this duct. And something that you should know about is that different vibrations happen at different wavelengths. That is the definition of the vibration. So let me say it a different way. The sounds that are made produce different wavelengths. And so different wavelengths can penetrate and go farther in your ear. So when we hear really low notes or versus really high notes, it's actually being processed in different areas of our ear depending on the frequency of the sounds. Okay, so if I look here, again, this is the cochlea. The low frequency sounds are going to travel the farthest into our cochlea, whereas the high frequency sounds are going to be heard towards the beginning of that tube I was describing. And these nerves are then attached through the brainstem and they go up into the brain. And then your auditory cortex is in your temporal lobe. Hopefully you remember where that is, your temples, right? Kind of right above your ears there. And that's going to be where we process sound in our brain. So you need to remember that the whole idea of action potential and that neurons are connected to other neurons and that the regions of our brain have different cortexes. So the auditory cortex is in your temporal lobe. And interesting, your hearing passes through your thalamus. All right, so there's a lot going on when we hear things, a lot more things than we possibly think. So now what we're going to do is we are going to focus on the organ of Corti. And the organ of Corti is the part where we are going to find the basilar membrane. And let me get back up and show you this up here, okay? So remember, we're looking in the cochlea, and we're looking at the organ of Corti, and the cochlear duct is where the sound is going to travel down, okay? So in the organ of Corti, you have a number of structures that are highlighted right here in this little section. So I want you to notice that this is like a Y. All right. So in this Y, there is, this Y is called the cochlear duct. Okay. And that's where the sound is traveling down. And that cochlear duct is Y shaped. And in that, we find that organ of Corti. So if I take this square and I make it big, I'm going to be looking at the tectorial membrane, the little hair cells that are in there, the basilar membrane. Remember, basal is going to be your base level. And then your nerve fibers are connected to those hair cells. So look at where the nerve fibers come up and are attached and attached and attached and attached. And they're attached to those hair cells. And the hair cells are under the tectorial membrane. Now, if I look at this up close under a microscope here, here is the base membrane. Here are the little hair cells that are sticking up to the tectorial membrane. Okay, so let's go back and look at that here. So the tectorial membrane kind of wraps around and comes over the top. So it wraps around and comes over the top, and it is going to make it so those hair cells are only stimulated under the right conditions. So when we think about the olfactory bulb and your nose and how you smell, there's a mucous membrane that is going to help you collect the scent, okay? When we are here, there's going to be little hairs that are stimulated. It's the same idea. Those little hairs are connected to the neurons. The neurons are going to the brain, having us hear these things. Okay, so this right here is what's going to be vibrating when we stimulate those little hairs, and then those little hairs are going to carry it in the nerves to the brain. So the cochlea has that Y-shaped passage. There are 3 passageways there. The middle one is called the organ of Corti. It has those sensory hair cells, and the hair cells are stuck in a little gelatinous membrane we call the tectorial membrane. And this is what the tectorial membrane looks like under an electron microscope. All right, so here we have that layer on top, and here we have those little hairs that are sticking up in order to be stimulated by the sound vibrations, and then they're connected with nerves that take that message to the brain. Okay, and then you can see some other nerves that are here as well. All right, so there's a lot going on in your ear, and this is all microscopic. Okay, very, very small. And as that vibration passes through those hair cells, that information is carried to the central nervous system over the cochlear branch of the cranial nerve number 8. All right, so this is how it works. I've already gone over this again, but I'm going to read it to you again. The auricle collects the sound waves. Please remember your auricle is the outside of your ear that has the cartilage and skin, adipose tissue, okay? The waves hit the tympanic membrane, the eardrum, causes it to vibrate. Those vibrations are passed to the ossicles. Those are those little bones in your ear that we talked about. The vibrations are amplified and travel through that oval window, and that oval window is what sends it into the passageway of the cochlea. The cochlea and the tympanic membrane move down in order to hear different sounds, the different pitches, and they stimulate those little hair cells that are there. And once those hair cells are stimulated, that action potential is sent down the cochlear nerves, which then travels to the auditory section of your cortex, the auditory cortex. So if you think about the hearing test that you've taken, hopefully you've had one of those. If you haven't, we can arrange that through the school nurse. But the school nurse will play a number of different tones, a number of different sounds. And when you hear them, you raise your hand so that way they know that you heard them. And some people can be deaf to certain tones, and we can attribute that to specific regions of the cochlea being affected. So if, this part of the cochlea was somehow affected, then you wouldn't hear the tones that this part of the cochlea picks up. If you were affected here somehow, if somehow there was something wrong with that portion of the cochlea, you might not hear those tones, right? You might not hear really high tones. And interesting, you guys have experience with those cell phone ringers, right? The cell phone tones that you can set where adults can't hear them, but the children can. And sure enough, that is because when you're younger, you have more access to certain parts of your cochlea that you lose with age. So very, very interesting. That's hearing in a nutshell. It all depends on how your cochlea functions. And in your cochlea, you have that organ of Corti. And that organ of Corti functions with that tectorial membrane and those hair cells that are connected to the nerves going to the auditory cortex. Okay, one more video to go on balance, and that is going to conclude our special senses unit. So look for the balance video next. Thank you for watching.